Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we'll be looking at GCSE Physics series circuits. Today we'll be covering series circuits because there are two main types of circuits. So today we will be covering series circuit, however next time we'll cover parallel circuits. So the main thing here, I will explain to you what series circuit is, how does it work, and what are the rules as far as physics go. What are the rules that series circuit follows in terms of calculating voltage, in terms of calculating current, and calculating resistance. Now, so the important thing is that there are two types of circuits and these rules are very different. And what I really want to get across here, because the easiest way to remember those rules is truly by understanding in your head how electricity works in series circuit and then later on in parallel circuit, which we'll cover in the next video. Now, and that truly is the best way to do this. Now, it's quite hard sometimes to understand electricity, how it works. So this is what I will attempt to do. I will attempt to explain it in such a way so it makes sense in your head. So these rules simply becomes common sense for you, and therefore it will be very simple for you to remember them. So without further ado, let's get started. Okay, so here we have an example of series circuit, and here we have a cell with a positive end and negative end, and then the charge flows along this cable, goes through an ammeter, then carries on flowing, then it goes through two resistors, then it goes to two light bulbs, goes through another ammeter, and then hits the negative end of the cell. And that way we complete our series circuit. This is a series circuit because everything is connected in series. As in, what does it mean, series? Everything is connected one after another. So our charge sort of goes through every bit of it, and everything is connected in a sequence, in series, one after another. In parallel circuit, we would have a different situation where charge would split down two separate routes, whereas here, all of the charge needs to complete a same route, same single route, and that's why it is series circuit. Now, what do we need to understand? Well, series circuit, because all the charge goes through a single route, if at any point we get a breakage, a light bulb breaks or resistor breaks or simply a cable breaks, if we get any breakage at any point in a series circuit, it will simply stop working. The entire circuit will go out, which is why a lot of modern electric appliances are often opt for parallel circuits. However, series circuits still play a very important role in today's electronics. So that's important. Series circuit, if it breaks anywhere, then the entire thing just goes kaput. Now, what do we need to understand in terms of the way voltage, current and resistance behaves? Well, let's start with voltage perhaps. So in order to understand this, voltage, I will remind you, voltage is the pushing force that drives the charge forward. So that's provided by cell, essentially. So here we have a maximum voltage, and here we have a minimum voltage, and that difference will give us a total potential difference. Because basically cell provides the voltage, the driving force. Now, how do we determine voltages across all these different points? Well, voltage is measured by In series circuit, voltage is measured by adding up the potential differences of all these different components. So in this case, we have a voltmeter here and here through each of the light bulbs. So here, total voltage would be equal to voltage 1 plus voltage 2. And that makes sense because essentially these are two places where that potential difference can get used up. Yeah, technically you will lose some in resistors as well, but I'm not including that for the sake of simplicity. Those are two main places where you can use some driving force, so therefore you get potential difference across. So essentially any difference that you get here will be a sum of differences throughout the entire circuit, because all of the charge goes down a single route. So any difference that you see here will be differences across the different component in circuit, so it will make a sum. And that's the way to sort of understand it in a head. Now, what happens with the current? Current stays the same. Current stays the same throughout the entire circuit. How do we understand this? Well, because current is defined as a rate of the flow of charge. So, because we have a series circuit, no matter where we are, the current will be the same. Throughout the circuit, the current will be the same. Because as the charge flows, essentially, you can think of it as a big traffic. You can think of it as a big traffic. So even if we have a slowdown of charge here because of the resistance, then we can think of it as a traffic. So if the cars slow down here, then these cars need to slow down here as well, because the road is jam-packed full of cars, and they are all stuck in traffic on the backlog because we get a slowdown here. We get a slowdown here as well. So the cars sort of are stuck in a traffic. If we remove all of these components, then these cars can start going fast again, and that backlog gets cleared, and then everything starts moving fast. If we start moving slow at any point, then we get this sort of backlog of cars, if you will, and therefore they all have to slow down. And that's very much the same with the charge. So if the charge slows down here, i.e. the current drops here, then the current will drop everywhere. So that's in series circuit. So in series circuit, current is the same across the entire circuit. So here we can express this as such, that current is the same here as it is here. So I1 is equal to I2. Now, sorry, I'll just add these quickly here to explain that. Okay. Now, resistance, again, let's go back to how to think about this, because this is the best way to remember all these different behaviors. If you know how to think about electricity, how to think about its behavior, it will just become common sense to you guys. So again, we have charge flowing around. And again, okay, let's go back to the cars. So here we have a tightening, here we have a tightening, and here we also have tightening technically. But let's just take into account these. Let's ignore these guys for a while. So here we have a tightening of the road, and here we have a tightening of the road, and cars are finding it harder to get across these two bits. They have to slow down. So these cars slow down a bit. So everything else has to slow down a bit. Then they go faster, but then they slow down again. So they slow down in two places. So the movement of those cars, so if we add resistances here and here, we get the total resistance. The total resistance is basically the resistance, the sum of all these different resistances across the circuit. Because we have to just add, because everything goes through the same route, we just add up all these different places where the resistance increases, where it's high, and that will give us total resistance. I mean, again, I will remind you there is a resistance across everything, but it is very small in a cable compared to, say, resistors. So in terms of electronics, we usually ignore the resistance in the cable, and we talk about the resistance in the actual components. So resistance in a series circuit is added up, so you add it up. So again, total resistance is equal to R1 plus R2. And that's how to think about it, that there are all these different places where resistance is placed on the current and is just affected. If we add these two and they're the same, it will be double with two resistors compared to a single resistor, and that is a very different behavior to what happens in a parallel circuit, which we will talk about in the next video. So this is it for today, guys. Thank you very much for watching my videos. I really appreciate when you guys watch my videos. If you want to stay up to date on daily math, science and biomedical science videos, hit that subscribe button below. If you think this video helped you, which I really hope it did, give me a big old thumbs up. If you have any questions, just shoot me questions in the comments. I will answer them to you as soon as possible. Also, don't forget that we have a Twitter page now. There is lots of amazing content on the Twitter page, anything from science jokes, maths jokes, to some actually useful links that may help you with some career decisions and things as such. So to access our Twitter page, check out our channel page. On the right hand side of our banner, you will see a little Twitter icon. Just smack that icon and that will take you straight to our Twitter page. Thank you again for watching and see you next time.